Hi everybody, today we're going to do a probability introduction. Say you apply for a job and learn there were 100 applicants. You might consider your chances of getting hired as 1 out of 100. Probability is the mathematical study of uncertainty and randomness, like our uncertainty about being hired for the job. Let's talk about a few foundational definitions. An experiment is what we're observing. The outcome is any result of an experiment. The sample space is the collection of all possible outcomes, and an event is a set of the outcomes. Let's go back to our job example. If we were given a frequency distribution of the applicant ages and wanted to find the probability that someone 25 to 34 is hired, we could say the probability of 25 to 34 is the frequency 42 over 100, which is 42%. We formed our probability by looking at the number of ways the event could occur divided by the total in our sample space. Let's find the probability that someone under 55 is hired. This time, our probability of under 55 is 100 over 100, which is 100%. Everyone that applied fell into this category of under 55. We could also look for the probability that someone over 55 is hired. This time, because no one is over 55, our probability is 0. This brings us to a few important probability rules. The probability of any event E is always greater than or equal to 0 and less than or equal to 1. The probability of an event not in the sample space occurring is 0. And the sum of all probabilities in the sample space has to add up to 1. Probability distributions will feel a lot like frequency distributions. Here's the difference. Frequency distributions summarize data. Probability distributions predict outcomes. When we look at our applicant age and the frequency, we can find the relative frequency, but we don't know who actually got hired. We can only make a prediction. In a similar way, we could think about rolling a 6-sided die. We would predict that any particular number coming up has a 1/6 probability of happening. So let's roll a die one time. And we got the number 6. If we roll the die again, the probability of landing on a 6 is still 1 over 6. The fact that the 6 came up doesn't change the probability of future rolls. We can see the second time we rolled the dice, we got a 3, but again, that doesn't mean the 3 is more likely or less likely to occur on successive rolls. So just because something did happen in the past doesn't guarantee it will happen in the future, which is what probability models try to predict.